everyone, welcome back to A's Data Science. Today we are going to do statistics to weekly mock of week 1 and week 2. So, without wasting the further time, let us just jump on the question. So, here is our first question, which states that use the following information for question 1, 2 and 3. The joint probability mass function of two discrete random variables x and y is given by. And in the first question, we have to find the distribution of variable s, which is basically x plus y. So, let us first try to find value of s associated with each x, y pair. The first pair is x is equal to 1 and y is equal to 1 with the joint PMF as 0.1. The value of s for this pair is basically 1 plus 1, which is 2. The next pair is x is equal to 1 and y is equal to 2 with the joint PMF as 0.2. The value of s for this pair is basically 1 plus 2, which is 3. Similarly, we have done this for all other pairs. You can pause the video if need and check them also. So, from the resulting values of s, let us pick the unique values of s and make the distribution. So the range of s is going to be 2, 3, 4 and 5 with the probability of 0.1, 0.4, 0.4 and 0.1 respectively. Now, let us first understand how the probability of 2 is 0.1, for 3 it is 0.4 and so on. Since there is only one pair of x and y which have the value of s as 2 and a joint PMF associated with it is 0.1, so the probability of s is equal to 2 is also going to be 0.1. Similarly, there are the two pairs of x and y for which the value of s is 3 and a joint PMF associated with them are 0.2 and 0.2, so the total probability associated with s is equal to 3 is 0.2 plus 0.2, which is basically 0.4. Hence the correct distribution for the variable s is equal to 2 with the probability 0.1, s is equal to 3 with the probability 0.4, s is equal to 4 with the probability 0.4, s is equal to 5 with the probability 0.1. So, the correct option for question number 1 is option B. Let us now see the second question. In the second question again, we have to find the distribution of a variable which is basically the variable z, and it is given that z is equal to max of x1, x2. It basically means that from the pair of two numbers we have to select the maximum number or greater number, and that number is going to be the value of z associated with that particular pair. So, the range of z is going to be 1, 2 and 3. And the probability associated with the each value in this range is 0.1, 0.7, 0.2 respectively. So, the correct option for the question number 2 is option C. In the third question again, we have to find the distribution of a variable which is basically the variable z, and it is given that z is equal to minimum of x1, x2. It basically means that from the pair of two numbers we have to select the minimum number or the smallest number, and that number is going to be the value of z associated with that particular pair. So the range of z is going to be 1 and 2 and the probability associated with them is 0.6 and 0.4 respectively. So the correct option for the question number 3 is option A. Let us now see the question number 4, and again this question shares the common data with the question number 4 and question number 5. Consider the random variable x and y and the joint PMF is given below. From the set of given options, we have to select the correct options. The first option is asking that whether random variable x and random variable y are independent or not. We know that if two random variables are independent means that their joint is equal to product of their marginals. And if we encounter even one single joint PMF where it is not equal to the product of their marginals, then it is going to be a dependent variable. Let us first see how can we find the marginals. Suppose we want to find the marginal of random variable x is equal to 1, and what we have to do is basically that we have to fix x is equal to 1 and vary it over all the values of y and sum or add all the joint PMF that we get. That resulting sum is going to be the marginal PMF. First, let us find one marginal by ourselves, or let us take an example for finding marginal. Let us find the marginal PMF of x0, which is basically probability of x is equal to 0, y is equal to 0 plus probability of x is equal to 0, y is equal to 1, which is basically 1 by 12 plus 1 by 4, which is equal to 1 by 3. Hence, the marginal PMF of x is equal to 0 is 1 by 3. Similarly, I have calculated the marginal of all other values. You can pause the video and do it yourself first and then match it. So, now if we try to check whether all the joint are product of their marginal or not, like suppose we do for fxy of 1, 1, then the marginal of fx1 is basically 1 by 2 and marginal of fy1 is basically 3 by 4, so its product is 3 by 8, which is same as the given joint. So, this joint passes the criteria for independent. Similarly, we have to do it for all the other joint PMF pairs, and even if we encounter one single pair where the joint is not equal to the product of their respective marginals, then the random variable is going to be dependent. So after checking it for all the other pairs, also be concluded that joint is equal to product of their reflective marginals for all the pairs, hence variable x and variable y is going to be independent of each other. Option 1 is correct. Option 2 says that x and y are dependent, so this option is going to be wrong. In the third option, we have to find the portability associated with x less than or equal to 1. Probability of x less than or equal to 1 basically means that probability of x is equal to 0 plus probability of x is equal to 1, which is basically 1 by 3 plus 1 by 2, which is 5 by 6. Hence this option is also correct. In the fourth option, we have to find the conditional probability of y is equal to 1 under the condition x is equal to 2. We just found that x and are independent, and we know that if two variables are independent of each other, then conditional is equal to marginal means that probability of y is equal to 1 under the condition x is equal to 2 is basically equal to probability of y is equal to 1, which is basically 3 by 4. So the correct answer for this is going to be 3 by 4, but the given answer in this option is something else. Hence, this option is wrong. Let us now see the question number 5. Here we have to find the value of given equation, which is basically 1 by probability of x less than or equal to 1 and y is equal to 0 plus probability of x is equal to 2 and y is equal to 1. Let us first find the probability of x less than or equal to 1 and y is equal to 0. Since x and y are independent, means probability of x less than or equal to 1 and y is equal to 0 is equal to probability of x less than or equal to 1 into y is equal to 0. It is basically 5 by 6 into 1 by 4, which is basically 5 by 24. Now, let us find the probability of x is equal to 2 and y is equal to 1. It is also equal to probability of x is equal to 2 into probability of y is equal to 1, which is 1 by into 3 by 4, which is equal to 1 by 8. Now, if we calculate the denominator part, then it is basically 5 by 24 plus 1 by 8, which is 1 by 3. So, the answer for this question is going to be 3. Let us move to the next question. So the question number 6 and 7 shares the common data. In a bookstore, there are two types of books, type 1 and type 2. Let x denote the number of books of type 1 that is sold in a week. Let y denote the number of books of type 2 that is sold in a week. Suppose x and y follows the Poisson distribution with parameters 2 and 3, respectively. Let z denote the total number of books of type 1 and type 2 sold in a week. Assume that x and y are independent. So, the question number 6 asks which of the following option are true. Both x and y follow Poisson with parameter 2 and 3 respectively. Z will also going to follow Poisson with parameter 3 plus 2, which is 5. So, correct options for this question are option B and option D. Let us move to the next question. Question number 7 says that find the probability of x is equal to 1 under the condition z is equal to 5. So we know that z is the total books sold in a week and is the number of type of books sold in a week. We know that probability of x under the condition z will follow binomial distribution. So if we solve the binomial distribution with parameter n is equal to 5 and p is equal to 2 by 5, then the answer we will get is 0.26. Hence, the answer for this question is 0.26. So, again, question number 8 and 9 is going to share a common data. The data states that two chess games are played between Anand and Kasparov. The probability that Anand wins the first game against Kasparov is 0.6. The probability that Anand wins the second game given that he won the first is 0.8, and the probability that Anand wins the second game given that he lost the first is 0.5. No game is drawn. Let x1 and x2 are two random variables defined as xi is equal to 1 if Anand win the game. Else it will be 0. The question number 8 asks, find the correct joint PMF of x1 and x2. Okay, so x1 is basically result of first game and x2 is basically the result of second game. Both have the same range of 0 and 1. It is given that probability of x1 is equal to 1 is 0.6. So, from this point we can also find the probability of x1 is equal to 0, which is going to be 1 minus 0.6 means 0.4. There are two more conditional probabilities given as probability that Anand wins the second game given that he won the first is 0.8 and probability that Anand wins the second game given that he lost the first is 0.5. Let us see the first conditional probability, which says that probability that Anand wins the second game given that he won the first is 0.8. We know that joint is equal to conditional into marginal. So let us first find the joint PMF of fx1 times 2 of 1, 1, which is equal to probability that Anand wins the second game given that he won the first into probability of x1 is equal to 1, which is 0.8 into 0.6, which is equal to 0.48. So, the joint PMF of fx1 times 2 of 1, 1 is equal to 0.48. It is given that probability of x1 equal to 1 is 0.6. Since it is the marginal for x1 equal to 1. So using this 0.6 and 0.48 we can find the value of fx1 times 2 of 1, 0 as 0.6 minus 0.48, which is basically 0.12. Now, let us use the second conditional probability that is given. Probability that Anand wins the second game given that he lost the first is 0.5. Let us find the joint PMF of fx1 times 2 of 0, 1, which is equal to the probability that Anand wins the second game given that he lost the first into probability of x1 is equal to 0, which is equal to 0.5 into 0.4, which is equal to 0.2. So, the fx1 times 2 of 0, 1 is 0.2. Using probability of x1 is equal 1, we find the probability of x1 is equal to 0, which is 0.4. So, the fx1 times 2 of 0, 0 is going to be 0.4 minus 0.2, which is 0.2. Hence, the correct option that matches with our joint PMF is option C. Let us move to the question number 9, which says that find the probability that Kasparov loses the second game. Means that we have to find the probability of fx is equal to 1, which is basically marginal of x2 equal to 1. It is 0.48 plus 0.2, which is basically 0.68. Hence, answer of question number 9 is 0.68. Let us move to the next questions. So, the question number 10 and 11 shares common data. The data says, suppose that the number of customers visiting a KFC on a particular day is in follow Poisson with parameter 5. Assume that each customer purchases a classic chicken zingers with probability 0.3. independent of other customers and independent of the value of n. Let x denote the number of customers who purchase a classic chicken zingers in a day. Let y denote the number of customers who do not purchase a classic chicken zingers. Question number 10 asks, find the marginal distributions of x and y. Here n is equal to number of customers visit KFC in a day. And then follow the Poisson with parameter 5. X is equal to number of customers who buy the classic chicken zinger and Y is equal to number of customer who do not buy the classic chicken zinger. Probability of buying chicken zinger is given as 0.3. First of all, both X and Y will follow Poisson distribution. We know that lambda is given as n into P. So, lambda for X will be 5 into 0.3, which is basically 1.5. Here we choose P is equal to 0.3 as X is number of customer who buy chicken zinger. So, X follow Poisson with parameter 1.5. Similarly, lambda for Y will be 5 into 0.7, 0.7 because it is the probability of not buying zinger. Hence, Y follow Poisson with parameter 3.5. So, the correct option for question number 10 is option C. Let us now see question number 11. We have to find the probability of x is equal to 3, y is equal to 3. Since it is given that buying a classic chicken zinger is independent of other customers, so it means that X and Y is going to be independent of each other. So, probability of X is equal to 3, Y is equal to 3 is basically probability of X is equal to 3 into probability of Y is equal to 3. Let us first find the probability of X is equal to 3 using the formula of Poisson distribution. The probability we get is 0.1257. And similarly, the probability of Y is equal to 3 is going to be 0.2158. So the probability of X is equal to 3, Y is equal to 3 is 0.1257 into 0.2158, which is equal to 0.0271. Hence, the answer of this question is 0.0271. Let us now move to the next questions. So again, question number 12 and 13 shares the common data. The data says that x1, x2, x3, so on x10 are 10 I D Bernoulli to buy 3 sample. Let y be a random variable defined as y is equal to x1 plus x2 plus so on till x10. Question number 12 asks that which of the following options are correct. So, this question is very easy, I guess, and I guess you all might have easily solved this. Here, the y will module into binomial distribution with the n is equal to 10 and p is equal to 2 by. So, option B and E are correct options for question number 12. Let us see question number 13 now. Find the value of x1 is equal to 0 under the condition y is equal to 8. x1 is going to follow the Bernoulli with probability of success is equal to 2 by 3. And y is going to follow the binomial with n is equal to 10 and p is equal to 2 by 3. So, the probability of x1 is equal to 0 under the condition y is equal to 8 is equal to probability of x1 is equal to 0 intersection y is equal to 8 by probability of y is equal to 8. Let us first find the probability of y is equal to 8. It is going to be equal of 10 choose 8 into 2 by 3 to the power 8 into 1 by 3 to the power 2, which is going to be equal of 0.1957. Let us now see the probability of x1 is equal to 0, y is equal to 8. It basically means that from the 9 trial there should be 8 success, which is equal to 9 choose 8 into 2 by 3 to the power 8 into 1 by 3, which is equal to 0.0391. So the probability of x1 is equal to 0 under the condition y is equal to 8 is 0.0391 by 0.1957, which is nearly equal to 0.2. Hence the answer of question 13 is going to be 0.2. Let us now see the question number 14. Suppose x1 and x2 are IID binomial with n is equal to 10 and p is equal to 1 by 3. Let y and z are two random variable defined as y is equal to x1 plus x2 and z is equal to x1 into x2. Which of the following options are true? So the only correct option from the given sort of option is option number 1. Let us now move to the last question of this mock. It states that a two-digit number from 00 to 99 is selected at random. Let x be the digit in unit place and y be the digit in 10th place. A new random variable z is defined as z is equal to max of x, y minus minimum of x, y. Find the probability of z greater than or equal to 2. Here, it is given that x is the unit place, so the range of x is going to be from 0 to 9, and similarly y is given as the 10th place, so the range of y is also going to be 0 to 9. If we try to understand the variable z, then it is basically the absolute difference between x and y. From 00 to 99 there are 100 pairs of number that is possible, and each is going to be with the probability of 1 by 100. Probability of z greater than or equal to 2 can be written as 1 minus probability of z less than 2. And probability of z less than 2 will be equal to probability of z is equal to 0 plus probability of z is equal to 1. First, let us find the probability of z is equal to 0. So the pairs for which the absolute difference is going to be 0 is basically 1 0, 0 1, 1 2, 2 and so on 9, 9. There are total 10 such pairs, so the probability of z is equal to 0 will be going to be 10 by 100, which is basically 0.1. Similarly, let us find the probability of z is equal to 1. The pairs for which the absolute difference is going to be 1 are 0, 1 1, 2 2, 3 and so on 8, 9, and reverse of all these means like 1, 0. So, the probability of Z is equal to 1 is 18 by 100, which is 0.18. Hence, probability of Z less than 2 is 0.1 plus 0.18, which is 0.28. So, probability of Z greater or equal to 2 is 1 minus 0.28, which is 0.72. Hence, answer for question number 15 is 0.72. Okay, so that is all for the mock of Stats-2. If you guys have any doubt regarding any question, then do let me know in the comment box. Also, if you have any suggestion, then please share it. And at last, don't forget to like